Okay, let's dive into this. Welcome to today's Explainer, where we're looking at what is absolutely one of the most extraordinary, mind-bending projects happening in science right now. We are exploring the very real quest to decode animal language using incredibly powerful artificial intelligence. You know, for as long as humanity has existed, we've wondered what our animals are actually thinking, but that idea has always been restricted to myths and fairy tales. Well, today, armed with the most powerful AI ever built, some of the smartest scientists on Earth are trying to finally cross that barrier.
So I want you to imagine a fun, hypothetical scenario for a second. Imagine waking up tomorrow morning, walking into your kitchen, and your dog looks you dead in the eyes and says, "I'm hungry. And by the way, I've been trying to tell you that for 10 years.
Or maybe your cat jumps up on your lap, stares at you with those deep, mysterious eyes, and communicates this: "I actually do love you. I just choose not to show it." It's complicated. I mean, it sounds exactly like a Disney movie, right? But the crazy thing is, because of recent technological breakthroughs, this concept is rapidly moving from the realm of fiction right into actual scientific reality.
Which brings us to Section 1, the animal language mystery, and our shift from fables to science. We've always written stories about talking animals, right? From ancient myths to Aesop's fables to Dr. Dolittle. But here's what science has quietly discovered over the past few decades. Animals are not silent, they aren't simple, and they are definitely not just reacting blindly to instinct. They are communicating constantly and complexly in ways we are literally only just beginning to understand.
What is truly fascinating is the sheer level of detail animals can convey. Take prairie dogs, for instance. Biologist Kon Slobodnikov spent 30 years studying them in Arizona, and his findings completely shocked the scientific community. It turns out prairie dogs don't just make generic alarm calls. They have a sophisticated, highly descriptive language. When a hawk flies overhead, they make one specific call. When a human walks by, it's a completely different call. But incredibly, and this blew my mind, if that same human walks by again wearing a different colored shirt, the call actually changes to describe the new color. They are actively encoding color, size, shape, and speed into their calls. This tiny little rodent essentially has a more complex warning system than most human languages have words for danger.
And hey, it's not just rodents. Let's talk about the number 20. Back in 2013, scientists at the University of St. Andrews confirmed that dolphins develop unique signature whistles, which are essentially personal names, to call specific individuals. Not only that, but dolphins remember the signature whistles of friends they haven't seen in over 20 years. Just let that sink in. That is the longest social memory of any non-human animal ever documented.
We also see this incredibly deep emotional communication in other species. Elephants, for example, don't just communicate, they grieve. Researchers have identified highly specific distress calls associated with death that spread grief through entire elephant communities. Scientists have even documented elephants returning to the bones of deceased family members years later, standing in total silence, showing clear signs of recognition, mourning, and deep emotional resonance.
And then, of course, there's the insect world. Honeybees perform something called the waggle dance. It's this precise, figure-8 movement that communicates the exact direction, distance, and quality of a food source relative to the sun. The angle encodes the direction, the duration encodes the distance. This is a spatial, mathematical, symbolic language, and it's happening inside an insect with a brain literally the size of a sesame seed. The reality is, the animals have been talking all along. We just didn't have the technology to listen.
Moving into Section 2, how AI changes everything. The catalyst. While scientists knew animals were communicating, cracking the code was nearly impossible for human researchers alone. But now, the exact same large language models powering tools like ChatGPT, the tech that translates human languages and recognizes massive data patterns, they're being trained on animal sounds instead of human text.
A prime example of this is this study of whale codus. Project CETI, the Cetacean Translation Initiative, launched in 2022 specifically to decode sperm whale communication. Whales use these codas, which are really complex sequences of clicks. They feature regional dialects and shared family patterns. Project CETI is out there deploying underwater microphones and cameras all across the Caribbean, feeding millions of these recordings into a massive AI model. They genuinely believe sperm whales might have a communication system equivalent in complexity to human language. If the AI can crack the code, it would arguably be the most significant scientific discovery in human history.
And this breakthrough is building across all different kinds of species. The Earth Species Project, which also launched in 2022, is using large language models on multiple species simultaneously. Their whole theory is that if AI can learn the patterns of human language without being explicitly told what a word means, it can do the exact same thing for animals. They've already used AI to identify individual animals from their calls with incredible accuracy. And by 2024, they announced early results showing they'd found consistent structural patterns in the vocalizations of Egyptian fruit bats. The AI is actually finding the patterns that encode meaning.
But here is where it gets wild. Scientists aren't just listening anymore. They are already talking back. There was this incredible experiment by scientists in Germany and the Czech Republic. First, they developed an AI to decode those complex bee waggle dances we talked about earlier. Second, they built a robotic bee, inserted it right into a real hive. And third, they had it perform AI-generated fake dances. And guess what happened? The real bees flew exactly where the robot told them to go. They are actively talking to bees, and the bees are listening.
Now for Section 3, talking to our pets, decoding dogs and cats. Let's talk about the animals we actually share our living rooms with. Dogs have been living with humans for 15,000 to 40,000 years. Through all that coevolution, they have developed an extraordinary sensitivity to human communication. They read our facial expressions, they follow our pointing gestures, and they respond to our emotional states in ways literally no other animal does.
And this brilliantly illustrates just how deep that connection goes. 1,022. That is the number of individual objects a border collie named Chaser learned to recognize and retrieve by name before her death in 2019. Think about that. It is the largest vocabulary ever documented in a non-human animal. They are constantly listening to us and absorbing our language.
So what happens when we use AI to listen back to them? Researchers at companies like Amazon, Google, and a startup called Zoolingua, which was actually founded by Dr. Khan Slobodikov, the same guy who studied the prairie dogs, are currently building AI apps to do exactly this. They're analyzing dog barks, whines, growls, body language, and facial expressions to accurately tell you what your dog is feeling and communicating. Early tests of these apps are reportedly surprisingly accurate.
Cats, on the other hand, well, they're a bit more complicated, which is very on brand for cats. Studies show that cats actually developed a wider vocal range specifically when living with humans. Back in 2023, researchers at Lund University in Sweden found that cats use very specific melody and pitch variations to basically manipulate and communicate with us. They literally developed the feed me meow because they learned it triggers a nurturing response in humans, kind of similar to a baby crying. AI is now being trained to distinguish between these highly specific feline pitches.
Which leads us to Section 4, the great ethical dilemma, the morality of listening. Discovering that animals have rich, complex emotional lives, that they feel joy, grief, fear, and love at levels we never fully imagined, is philosophically incredibly complicated. Because we really have to ask ourselves, what happens if we actually succeed in translating all of this?
Consider this for a moment. If a cow can communicate, "I am afraid, I don't want to die," how does that change the ethics of farming? It forces us into a very uncomfortable state of moral reflection regarding our entire food system. If livestock can articulate their fear to us in a way we can instantly understand, turning a blind eye becomes infinitely harder.
Or think about this scenario. If a chimpanzee can tell us, "I understand what a mirror is, I know I exist, and I think about my future," what legal rights should they have? The legal implications of a primate actually demonstrating self-awareness and articulating thoughts about their own existence would completely upend how our justice and legal systems define personhood.
And finally, if a whale can communicate across oceans to share history, culture, and perhaps even wisdom, what does it mean that humanity hunted them to near extinction? The legendary primatologist Dr. Jane Goodall has stated that if we could truly understand animal communication, it would be the most morally transformative discovery in human history. It wouldn't just change science, it would fundamentally change what it means to be human.
So the crucial point is understanding exactly where we are right now with the tech. Looking at our capabilities today, we can absolutely use AI to decode emotional states, identify individual animals, detect structural patterns in calls, and, as we saw, even direct bees. But there are limits to what we can do yet. We cannot have fluid two-way conversations. We haven't fully verified if animal communication has strict grammar rules like human languages do, and we can't completely confirm their subjective experiences. We still have massive scientific hurdles to overcome.
But look at the timeline predictions from leading scientists. Right now, at 0 years, AI is already decoding animal emotions and identities. In just about 5 years, researchers at Project CETI genuinely hope to crack those complex sperm whale codas. And in 10 years, scientists believe we could see potential basic AI-mediated communication with select species. We are standing on the absolute edge of something historically extraordinary.
Which brings us to our final section, Section 5, a new interspecies future. We were never listening properly. What if the reason we haven't understood animal communication isn't because animals don't have language? What if they have had language all along, but humanity just didn't have the technology to listen properly? What if whales have been singing poems across oceans, and dogs have been trying to tell us something vital, but we just weren't equipped to hear it? You know, the universe spent 3.8 billion years evolving life on this planet. Millions of species, each with their own unique way of experiencing the world and their own form of communication. For almost all of human history, we have been totally isolated, believing we were entirely alone in our ability to talk about it. But AI might finally bridge that 3.8 billion year communication gap that has separated us from every other species. And when we finally cross that barrier and hear the full complexity of their inner lives, it will undoubtedly make us more humble and far more compassionate.
Because perhaps the most important conversation humanity has ever had hasn't even started yet. So I want to leave you with one final thought to reflect on today. If you could talk to any animal, what would you ask it? Just let that sink in for a moment. Thanks so much for joining me on this explainer. I really hope this changes the way you look at the natural world around us. See you next time.